on robotics. I am Professor Ghoshal. So we'll wait for a few minutes and let other people come. So I can see a few people who have joined. So we'll wait. So please keep your questions ready and I'll try and answer them. Yes, good morning. Yes, I know. Tell me. Okay, fine. I'll take a look at it. I am in a meeting right now. I'll do it in the next 1 hour. Okay. Okay. Uh, so I can see Krishna Kumar. Krishna Kumar, are you there? Krishna Kumar, are you there? I can see Krishna Kumar. Then I can see Sanjeev Tripurari. And there is somebody who is joined using Redmi. So who wants to go first? Krishna Kumar, you have a question? You can type in your question. You can ask me. You open your microphone and ask me whatever you want. Are you there, Krishna Kumar? Krishna Kumar Singh. Okay. Sanjeev, yeah, you can attend, and it's good that if it'll be nicer if you can ask questions also, Sanjeev.
So on YouTube, there is one guy who is asking how hook joint has 8 degrees of freedom.
8 degrees of freedom. Okay. Okay, good. So hook joint. Okay, so hook joint normally allows two relative degrees of freedom. So if you have one rigid body, it has 6 degrees of freedom, correct? Rigid body, 6 degrees of freedom. I am also typing the answer in the chat. Okay, so the second rigid body is connected by a hook joint. Okay, so the hook joint allows two relative degrees of freedom. If you see the picture, hook joint allows two relative degrees of freedom. So the answer to your question uh, is that the total degrees of freedom is 8. The hook joint does not allow 8 degrees of freedom. Okay. So total degrees of freedom of the two links, two rigid bodies connected by a hook joint is 8. Okay. So it is the hook joint itself does not have 8 degrees of freedom. Is that clear?
So I'm pasting the answer in the YouTube then.
Ah,
Okay.
so I have put this chat thing, so you can
Yes.
paste that answer in the YouTube. Okay, let's see who else is there. There is a person called Saurabha Shirgaonkar. Uh, do you have a question, Saurabha?
Hi, can you hear me?
Yes, I can hear you.
Um, so I've actually I just started this course last week, so I'm just going through the videos. I did find the first week to be a bit of a sudden jump, like because I'm not very familiar with the linear algebra aspects. I'm a little rusty on that. So will that be covered through the course, like as it goes along, or do I need to supplement it with some other material?
You see, one of the requirements for this course is you should know very basic linear algebra. So by basic, I mean you should know what is a matrix. Okay, you should know how to multiply two matrices. You should know what is the inverse of a matrix. And I don't need, in this course, you will not need to know very detailed uh, mathematical results of linear algebra, like row space and null space, and all those things are not really required. But what you should know is that when I say that rotation matrix is a 3 by 3 matrix, you should know what is that, what does that mean? Or if I say that R inverse is same as R transpose, okay, so you should know what the transpose and inverse means. So the proof of R inverse is same as R transpose is that there in the notes. But I am not going to go into what is the basic definition of an inverse or a transpose. That much you are expected to know. So a simplest thing would be that you can see the first few lectures. If there is some question which you don't understand at all, the words look Greek to you, you can type it in Google. I would do that. I wouldn't advise you to go in depth into a course in linear algebra. Does that answer your question?
Yes, that's very helpful. Thank you.
There is somebody by the name of Arjun. I'm sorry, I can't see the rest of your name.
Kolika.
Okay. So, do you have a question, Arjun? Are you there, Arjun? Okay. Maybe right now not there. There is a person whose name is not there, but it says Redmi. So, I am assuming Redmi is the name of the phone or the connection they are using. Are you there? Uh, are you there? I can see some name calling Redmi. Okay, let's go back to Arjun. Arjun, are you there? You don't have to wait, okay? If you can just, somehow indicate that you have a question and you can just go ahead and ask, okay? So I can see one more person, Rajesh. Rajesh, do you have a question?
Hello, sir.
Yes, go ahead, Rajesh.
Sir, I was the one who asked about that Hooks joints degrees of freedom, sir.
I see. Okay, good,
Yes,
good.
sir.
Is it clear now what I have written in the chat?
Sir, it's you told about it's a total degrees of freedom,
Huh.
but actually, when two Hooks joints are connected together,
Uh-huh.
what will be the degrees of freedom, sir? That is what actually one question was there in the assignment.
So
Sir.
if you have two hook joints,
Sir.
okay, so then the second, after the first hook joint, it is actually a link. Okay,
Yes,
so
sir.
although the link may not be a proper size and things like that, so you have
Okay.
one link, one hook joint, one more link, one more hook joint, like that it will
Okay.
be,
Okay,
and
sir.
then one more link. So then you can calculate the degree of freedom. You need to
Okay.
be careful. So there is this problem. What happens is if the hook joints are not connected in the same way, in
Okay.
some proper way, then that in between link can rotate on its own axis.
Okay.
So remember, I think in the course, in the robotics course, you will see two spherical joints connected together by a link. So
Mm.
in that case, there will be a passive degrees of freedom. So same thing can happen if you have two hook joints not connected in the right way.
Okay.
So that is the answer. That is the way you should think about what
Okay,
happens to
okay.
hook
It
joints.
depends on how it is connected. Then only we can calculate the degrees of freedom. Sorry.
Yes,
Yes,
correct.
sir. Yes, sir. Thank you, sir.
Where are you from, Rajesh?
Sir, Bangalore, sir.
Okay.
Yes, sir.
Okay, let's see if there's anybody else. There is a student by the name of Dilip Kumar Das. Do you have any question, Dilip? Dilip, are you there?
So Saurabh here.
Yes, go ahead, Saurabh.
Yeah. So what I wanted to know from you is alongside this course, like through this course also, like I wanted to see if there was a self-directed project I can take up to apply the learnings of this course.
Okay.
I mean, I'm sure there's like MATLAB simulations which this course would have. I was
Yes.
just wondering if you have any thoughts on what I could do as a self-directed project to apply the teachings here.
Okay. So where are you from, Saurabh?
I am based out of Belgaum, Karnataka.
Okay. So, are you a student or are you working somewhere, or what is the
Oh,
what is
I mean, right now I mean, I've been working for 10 years, but like I'm in a bit of a career break right now, so looking
okay,
to, yeah, upskill.
okay, okay, good. So in that case, see, there are one obvious thing would be, or simplest thing would be to take a look at some of the assignments in this
Mm-hmm.
course. Okay. So those assignments will, help you learn some. If you can do those assignments, then you will know a lot about this course. You know a lot about linear algebra, you know a lot about DH parameters, you know a lot about kinematics. Later on we'll do dynamics and control. So you will get to know a lot about multi-body kinematics, dynamics, control, and so on. So that is one way to, in some sense, upskill yourself. Okay. The other thing is, so there are these software tools which are available. Some of them are free, some of them are free up to some stage, and then some which you have to spend money. So if you look at, there is a software tool by a professor from IIT Delhi. Okay, Robo Analyzer. It's free. So you can go ahead and download that and you can try to see what it does. Then there is also a very commercial one. Okay. So that also will help you a lot. So let me just tell you the name of that one. Just give me a minute. Just 1 minute. I'm trying to find out. Pramod, this is some grog or something like that, no?
For which thing?
One software tool where you can see all these robots.
Okay, let me check.
It's a free tool for up till some amount for some simple things. But then
Like Adams?
Atoms is one. Okay,
Okay.
but there is one more which is more robot oriented. So yeah, so Saurabh, there is a tool called Atoms,
Okay.
which is a multi-body simulation system. Okay,
Okay.
but there is, just give me a minute. I need to.
And then there are so many simulators also nowadays.
That's what I
Rigid
was
body
trying to get at.
simulators.
One of the simulators I was
So it
trying to
is
get at.
so it's a Mujoko, and if you go
Uh,
for ROS, it's a gazebo, and then there are VBot simulator, and
uh,
then there is a NVIDIA simulator called Isaac Sim. Nowadays, like many people are using because it has a like parallel environment simulation capability, and
mm,
it uses GPU and all to accelerate the learnings. And there are like multiple rigid body simulators which has like specific advantage over the others. So if you want to simulate, let's say, wheel robot, so you will find some simulators will be better compared to others. And if you are looking for some good contacts, accurate contacts, so you should go with the Mujoko simulator, those like those.
yeah. Okay, so I found it. There is a software tool called RoboDK. Okay, it is ROBODK. Okay, if you type that in Google, So whatever Pramod was telling, those are also a little bit more advanced. But there is a simulator called tool called RoboDK.
Okay.
Somebody can if you type that in Google, you'll see.
Okay.
So it basically gives you a huge list of all possible robots which are there in industry. That is number one. Number two, you can play around. There's a nice GUI to that, and you can move the robot. You can see what it is doing. You can do things like path planning. You can do things like obstacle avoidance. You can do quite a bit of things. So like all this free software, no, you can only do little bit. You cannot make a very really complex system using RoboDK, but for initial things, it is fine. And as Pramod was saying, there are other simulators also for both robots, as mobile robots or quadrupeds or even bipeds. Various things are there. So as you know get conversed, once you get to know some of the basic tools, then maybe you can graduate to that.
Yeah, thank you. This is actually very helpful. This robotic, I just looked it up. It
Ah,
seems oriented towards industrial automation, and that is
yes.
indeed like the area I
Ah,
was looking to
yeah.
hopefully have a project in. So this is definitely a good suggestion.
Yeah.
Thank you so much.
Okay, you're welcome. Okay. Krishna Kumar, are you there now? Krishna Kumar, then Sanjeev. Sanjeev said that you are attending
Hello,
this
sir. Yeah,
session.
this is Sanjeev. So actually, I'm new for this one. I have more experience on software side. So I'm just
Aha.
exploring on the robotics. So that's where I'm taking up this course.
Okay, good.
Yeah.
So you can see these two software tools that I've written.
Yes,
One
sir.
is Adams, one is RoboDK.
Yes, sir.
And there are others also, many more.
Sure, sir. Yeah.
Okay. So both of these are free. Adams is free if you are a student. There is a student version which is free. RoboDK is also free till some level of complexity. So you will not be able to use it for real engineering and industrial problems, but you can learn.
Sure, sir. Yeah. Thanks.
Krishna Kumar, are you there? Arjun, are you there now? Do you have? So let me ask Sanjeev and Rajesh and all the others. So, what is your feedback on the lectures? Are they easy? Are they hard? Confusing? Clear?
It is detailed, sir,
Uh,
for a basic learner, for starting from the basic. Start from the basic. I
uh,
think it is correctly. So far, for about 2 weeks, I have gone through the lectures.
uh,
It is intriguing, and I am feeling it's okay, sir. That is actually what I want. I am getting that, sir.
okay, good.
Okay.
How about somebody else? Krishna Kumar or Arjun? Saurabh, did you look at the lectures, the video and the slide, whatever is there?
Yes, I've gone through the first week. I actually really enjoyed the lecture, especially the parts
Okay.
where you're talking about student projects.
Hmm.
Like that, that was really inspiring in the way that, okay, like learning this, so even I can maybe implement some of these and like complete one of these projects or do something of that sort. So it was like really good to learn. So I actually like the lectures, though I
Okay.
was a little confused all of a sudden with the certain linear algebra stuff. But I think with
Uh,
week two, I'll be able to pick up more of that through some additional learning.
okay. Okay, that's good. Pramod, are there any questions in either YouTube or in the forum?
No, sir. Like till now, there is no question. But let me check.
Uh, Arjun, you wrote, uh, I don't have any doubt, huh? That's what you said. Something like that, right?
Okay. So there is Abhijit.
Uh,
He is asking which big book sources they studied
uh,
in robotics.
okay. So I will advertise my book. Okay, so please buy my book. Okay, so these NPTEL lectures, if you buy the book, then it will be a big help. So the book, of course, has a little bit more, and some NPTEL lectures, the video and the practical part, you cannot see it in any book for that matter, but but you should buy my book. So if you type in, it's Oxford University Press, robotics. And it's not very expensive. I think it's less than 750 rupees.
Yeah, so I am giving the link.
Yeah.
Sir, I had one question
Ah,
regarding RoboDK. So I was just looking at the licenses, and they do have an educational license. I wouldn't
yeah.
suppose there is any chance for us to get an educational license through NPTEL.
We haven't done that. So if there are enough people, we can try that. See, if you have any student affiliation anywhere, it is free. But if you
Hmm.
But I am assuming you said that there's a career break. So
Yeah,
unless you are
correct,
not a student anymore,
correct.
if you send me one link, I will request NPTEL to give you access to RoboDK also for some time. I will try. I cannot promise anything. But if you have any friend who is a student, you can request them also.
Okay, okay. You mentioned send you a link as in link for the
No, no, no. You send me an email. Sorry, not a
email. All
link.
right.
You send me an email. So my email ID is this, and we'll see what to do.
Okay. Sure, sir. Thank you so much.
I will request, see if we can get hold of something for you, but I'm not sure.
Okay. Yeah, I mean, worth a shot.
Hmm.
Okay, there is a Abhijit on YouTube. He is asking, is NPTEL lecture will be enough to crack the exam?
Yes, Abhijit, the way NPTEL works is that there will be an MCQ uh, exam, MCQ type of exam at the end. Okay. And like NPTEL has this policy that 50% of the questions in the MCQ are directly from the lectures and from the material which is there in the lectures. So if you go through the lectures and if you understand, 50% would be, you would have seen that, something or other in the question, okay, in the lectures. Another approximately 20 to 25% is based on assignments. So if you have done the assignments, again, 20 to 25% will be directly related to the assignments. And the last about 20% is sort of open. You need to think a little bit. But again, nothing is really outside the contents in the lectures. But you might have to think a little bit. So there might be 2 or 3 concepts which are combined, and then an MCQ question is asked. Is that clear, Abhijit?
Yeah,
So
yeah, I'm
maybe.
writing it. Yeah, I'm writing it on the YouTube.
So that is the rule for all NPTEL courses. It is not only for this course. And the TA, Pramod Pal, you should ask questions to the TA. Huh? Please ask questions to the TA. So, and this will be, it can be either in the forum or by email. You can do all of that. Okay, so as I said, approximately nobody can tell you exactly. 50% is from lectures. Okay, another approximately 25% is from assignments. And the rest, another 20 to 25%, 20 to 25% open. So NPTEL has this terminology. Some are called recall. So the first 50% are called recall questions. Okay. Second are something which is a little bit more, and the third one is open. Okay. So every year there is a small changes. That's why it is approximately. It could be 60, 20, 20, or it could be 50, 25, 25, like that. Anybody else is there, Pramod?
Checking. Okay, so Sagar Arora is there.
Ah,
He's asking, sir, can you please explain how the planar pair joint has 3 degrees of freedom?
okay. Okay. So wait. Simplest is I should open that slide
I'm just
and then
pasting
it
the
will be
question in
easier.
the chat.
Ah, okay. So the answer to the question is straightforward. The three DOFs are X, Y, and rotation angle. Okay, so basically what you have is one plane on top of another plane. So the top plane can translate in X and Y and it can rotate. So no freedom in the Z. So not possible. So constraints are one, no motion out of the plane, no motion in the Z direction. Basically uh, normal to the plane. And the no rotations out of the plane. So it has 3 degrees of freedom and 3 constraints. I hope that is clear now. The answer is rotation about normal to the plane, which is a Z rotation basically, is okay, is allowed. Okay, but no motion out. So no motion along Z. Motion means linear motion, translational. So please take a look at the drawing, the sketch of the planar, uh, uh, planar pair joint, and you can clearly see it must always maintain contact. But while it is maintaining contact, X and Y motions are possible, and rotations about the Z are possible. Are there any, Pramod, are there any questions in that Excel file? No, huh? There needs to be an Excel file also, no? Okay, practice assignment. Okay, Um, so this is please ask TA to solve a few problems. So Pramod, maybe
Yes, sir.
Pramod, you can just see some old question papers or some old exams, and you can solve a few problems from there.
Okay. So, yeah, I can tell Mr. Sagar to send me an email. I will send them questions, assignments, or detailed question.
Ah,
Okay.
yeah. Books is you please buy my book. That is the simplest. That has many problems and other things. And the link is given by the TA. Anyone else? Krishna Kumar, you haven't asked a single question. Are you there?
No question this time, sir.
Okay. Where are you from? Okay. Is there anybody else? So you can also ask questions by email.
Sir, whether that your textbook is there, no, sir?
Huh.
Whether it includes that software, that is MATLAB exercises and all, is there, sir?
Not too many. Some are there. Not too many.
Okay. Okay.
And promote yours is promote yours is promote full
PRAMODPAL.
address.
Yeah, at the rate IS.
Anyone else? Any other person has any other question? You can unmute yourself and talk if you want to. So Bharat,
Yes, sir.
so we can wait for a few minutes and then maybe. Oh, it's already 12:30. Okay. So yeah, we can wait for a few more minutes and then close. Okay.
Okay, sir.
Pramod, there is no other questions, right? In anywhere?
Yes, on the YouTube there is no question, and on the chat box also there is no question.
Okay.
Also
So
in the
Bharat,
there is no question.
yeah. Bharat,
Yes, sir.
shall we close?
We can close the session, sir.
Okay, 2 more minutes and you close it. You don't have to wait for me. Okay?
Okay,
So
sir.
anyway, it's already 12:36. We were supposed to stop at 11:45, no?
Yes, sir. 12:45.
12:45. So we just another 2, 3 minutes, and after that you can close it. Okay. Thank you, Bharat.
Okay. Thank you,
Thank you,
sir.
Pramod. And thanks for all the questions to Rajesh and who else was there? Krishna Kumar,
Thank you, sir.
Rajesh, and Saurav. Yeah,
Thank you, sir.
yeah. Thank you. So, right hand rule, there is a Rajkumar Yadav. Okay. So, can people see my video? Okay. So, this is my right hand. Okay. Can you see the video?
Yes, sir.
Rajkumar Yadav. Okay. So, right hand means that suppose this finger is the x axis, this is y axis, then this will be the z axis. So, x cross y will be z. Okay. So x, y, and z. So this is, if you do this x, y, z using your right hand, that is called right hand rule. If you do it this way, this is my left hand. So this is whatever x, y, and z. You can see that it is opposite. So one of the axes is opposite. So it's a mirror image. So right hand rule is basically that you use your right hand to find x, y, and z axis, or actually only the z axis. That is important. Is this clear? Rajkumar Yadav, have you seen this? Pramod, anything else? Last minute question?
I don't see any question. Okay. Yeah. So Rajkumar has asked, right? Explain right hand rule. That's it.
Okay.
There's no question. No question.
Okay. Anyway, we'll stop at 12:45 because there will be some other NPTEL class scheduled. So we'll wait for another 4 minutes. It's fine. So Bharat, we'll wait for 4 minutes and then close.
Okay, sir.
Hello. हेलो. बढ़िया मस्त.
Can we end the session, sir?
Just 1 minute. I'll just write that 1 minute. Okay, I just said that you can send questions by email. So now we can close the session. Okay, Bharat, thank you.